Let's look at how the Diffie Hellman key exchange works. So the idea is two people want to share a symmetric key, but how do we tell each other what that key is in a private way? So we use the Diffie Hellman key exchange. There are two pieces to the public key. First is a prime number P, and the second is another number which we call G, and G must be a generator. So G satisfies the following property. By raising G to some power, so we take G to the n for some number n, you can get all values between 1 and P minus 1 mod P. So here's an example. So let's say P is equal to 5, and we'll use this because it's easy to do the calculations. And so 2 is a generator because when we raise 2 to different powers, so 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, but we take that mod 5 and we get 3. 2 to the 4th is 16, which mod 5 is 1. So we verify that we got a 1 by 2 to the 4th. We got a 2 using 2 to the 1. We got a 3 using 2 cubed. And we got a 4 using 2 squared. So we were able to get all of those numbers by raising 2 to some power and then taking it mod 5. Now, the two people that want to create a common symmetric key, let's call them Alice and Bob, and each of them choose an exponent. So those two exponents will be our private keys. So let's continue our example where the prime that we choose is 5 and our generator is 2. Alice chooses an exponent A equals 2. Bob chooses as his exponent B is equal to 3. Now the first thing is Alice will calculate G to the A mod P, and she sends it to Bob. So let's go ahead and do that calculation. So she takes the generator G, which is 2, her exponent, which is her private key, which is 2, we plug it in there, we take it mod 5, and she calculates 4, and she sends that to Bob. Now Bob is going to do the same thing, except instead of the exponent A, he's going to use his secret exponent B. And then he sends the result to Alice. So he takes our generator, 2, his secret exponent, 3, calculate it, mod 5. So 2 cubed is 8, 8 mod 5 is 3. That's the number that he sends to Alice. Now, how do Alice and Bob take that information that was sent to them and use it to create a common shared key? So Alice got G to the B mod P from Bob. She raises that value to the power of A. So she takes the G to the B, raises that to the power of A, and then takes it mod P. So in our example, Bob sent G to the B to Alice. G to the B was 3. Alice's secret exponent is 2. That's A. So 3 squared is 9. 9 mod 5 is 4. So Alice thinks that their shared symmetric key is 4. Hopefully Bob will be able to make the same calculation and get 4 as well. So Bob got g to the a mod p from Alice. He uses his secret exponent of b. And so he takes the result from Alice, which is g to the a, raises that to the power of b, and then reduces it mod p and sees if he gets the same value. Now remember that the number that Alice sent to Bob, which was g to the a, was 4. So he takes the number that Alice sent him, which is 4, raises it to his secret exponent, which is 3. So 4 cubed is 64, and 64 mod 5 is 4. So that's exactly the same number that Alice calculated, except, of course, she did it in a different way. So in our example, the shared key is 4, which is equal to g to the a mod b, g to the a to the b mod p. That's how Bob calculated it, whereas Alice calculated it using g to the b to the a mod p. And both of those values are equal to g to the power of ab mod p. And that's why the values are going to be the same. And so the bottom line is the shared symmetric key is going to be g to the power of ab mod p.